Welcome all. In last lecture we have seen the problems based on demultiplexer tree and the use of demultiplexer in the design of combinational logic circuit. Today we will see the encoders. Encoder is a combinational circuit which has n number of input lines. These are the n number of input lines and m number of output lines. These are the m number of output lines. This is a block diagram of encoder. An encoder produces m bit binary code corresponding to the n bit digital number applied at its input. That is, encoder accepts an n bit digital word and converts it into m bit another digital word. Here, for example, if we say a BCD number is applied at the input to be converted into a binary number at the output. That means in this example the encoder is BCD to binary encoder, means n number of inputs are BCD numbers and m number of output lines are binary numbers. Means using encoder we can convert a number or a input in one form into the output of other form. These are the types of encoders. First one is priority encoder, second one is decimal to BCD encoder, third one is octal to binary encoder, and last one is hexadecimal to binary encoder. All these conversions we have seen in the first unit of the subject. Those are mathematical conversion, but here in an encoder a combinational circuit is to be designed so that a given number can be converted into the another format. Now we will see the one by one. First one is the priority encoder. This is the block diagram of priority encoder having 4 inputs, that is D3 to D0, and 2 outputs Y1 and Y0. This is a special type of encoder. Now here, depending on the input lines, corresponding output we will get. Now if D0 is 1, corresponding to that we will get output as a 0 0. If D1 is 1, corresponding to that we will get output as a 0 1. If D2 is 1, we will get output as a 1 0, and if D3 is 1, then we will get output as a 1 1. Keep this sequence in your mind. Now here priorities are given to the input lines, that is D0, D1, D2, D3 are prioritized. If 2 or more lines are 1 at the same time, then the input line with highest priority will be considered. Now here D3 is having highest priority and D0 is having lowest priority. Means priority decreases from D3, D2, D1 to D0. That means if D3 is 1, here the example is given, then Y1, Y0 we will get as a 1 1 irrespective of other input. Similarly, if D3 is 0 and D2 is 1, then we will get Y1, Y0 as a 1 0 irrespective of other input. That is, for this case, if D3 is 0 and D2 is 1 and D1 and D0 are also at 1 1 position, then also we will get output as a 1 0, as D2 is 1, which is having highest priority as compared to D1 and D0. We will see this condition through the truth table. Here a short truth table is shown. Here the first condition, in first condition all the inputs are 0, then y1 and y0 are shown as a don't care condition, means we will not predict what the output status is. Now in second case, D0 is made 1, all other inputs are 0, then we will get output as a 0 0. In third case, D1 is 1, D3 D2 are 0 0. Irrespective of status of D0, we will get output with respect to D1 as 0 1, as from D1 and D0, D1 is having highest priority. In third case, D2 is 1 and D3 is 0. Whatever may be the input at D1 line and D0 line, we will get output as a 1 0, as D2 is having highest priority than D1 and D0. And in last case, D3 is 1, irrespective of input at D2, D1 and D0, we will get output with respect to D3 only as 1 1. In the last case, even though if D2, D1, D0 are at 1, we will get output with respect to D3 only, as D3 is having highest priority than D2, D1, D0. This is what is elaborated in this truth table in detail by considering all the input combinations of D3, D2, D1, D0. In first case, all the inputs are 0 0 0. Therefore we will get a don't care condition at output, means output can be anything. They can be in 0 0 state, in 0 1 state, in 1 1 state, or in 1 0 state. We cannot predict the output when all the inputs are 0. In second case, D0 is 1 and all other 3 inputs are 0, so we will get output with respect to D0. In third case, D1 is 1, D3, D2 are 0 and D0 is also 0, so we will get output with respect to D1 as 0 1. In next case, D3, D2 are 0 0, D1, D0 are 1 1. Now here D1 and D0 both are 1 1, so we are going to consider the input with respect to D1 only, as from D1 and D0, D1 is having highest priority, so we will get output as a 0 1. In next case, D3 is 0, D2 is 1 and D1, D0 are 0 0, so we will get output with respect to D2 as 1 0. Means for all these 4 cases, we will get output with respect to D2 only, whatever may be the D1 or D0. As D2 is having highest priority, we are going to get output as a 1 0 when D2 is 1, provided if D3 is 0, irrespective of input status at D1 and D0. And for next 8 cases, D3 is 1, whatever may be the D2, D1, D0, whatever may be the D2, D1 or D0, we will get output with respect to D3 only, as D3 line is having highest priority as compared to D2, D1, D0. So irrespective of D2, D1, D0, if D3 is 1, we will get output as a 1 1. This is how the priority encoder works. Means 4 lines are converted into 2 lines output. Now we have to get the output expression of y1 and y0 using kmap. As the inputs are 4 variables, so we are considered a 4 variable kmap over here. For y1, these entries are made onto the cells of kmap. After entry, we will get the kmap like this, which you are seeing in the PPT now. Now in this we will get 2 octet. This is the first octet, this is the second octet. For the first group of octet, we will get the expression as a D2. You already know how this expression can be considered or can be find out. For the second octet, we will get the term as a D3. So for y1, we will get the expression as D3 plus D2. Similarly, for y0, these entries of y0 are made available onto the kmap cells. Now here we will get 1 octet and 1 chord. For the octet, we will get the term as a D3, and for the chord we will get the term as a D2 bar D1. So y0 will be D3 plus D2 bar D1. Here in both the cases we have not considered this don't care condition to form any octet, chord or pair, as for that the input lines are at 0. Therefore we have not considered the don't care condition in any of the group. So using the two output expression, now we can draw or we can implement the priority encoder. Y1 is D3 plus D2, Y0 is D3 plus D2 bar D1. So we require D3 line, D2 line and its complemented line, that is D2 bar, D1 line and D0 line. So to get Y1 expression, we will connect D3 and D2 to the OR gate, which will give you D3 plus D2 output. And to get Y0, first we will get this term D2 bar D1 using AND gate. This AND gate can be connected to D2 bar line and D1 line, which will give D2 bar D1 term over here, and that term is ORed with D3. So D3 line is connected to OR gate to produce Y0 output as a D3 plus D2 bar D1. This is how we can design a priority encoder which converts a 4-line input into the 2-line output. These are the priority encoder ICs. The first one is 74147, which is a 10:4 priority encoder, means it is a decimal to BCD encoder. And the 74148 IC, which is a octal to binary priority encoder. We will see these IC in the next slide, means another encoders. Now we will see the decimal to BCD encoder. This is the block diagram of decimal to BCD encoder, which is having decimal inputs 0 to 9 and BCD output DCBA. This encoder converts decimal inputs into the BCD output. Now this is the truth table, which is showing the input lines from 0 to 9 and the BCD outputs. You already know how to write a BCD code of a particular decimal number. Using the same thing, the BCD of each decimal numbers are written in this output column. For 0, the BCD code is 0000. Likewise, the BCD code for all other inputs are written, and from this truth table we are going to find the equation of D, C, B and A, by which we can implement the decimal to BCD encoder. Now if you observe the truth table, from that output D is 1 only when decimal input is only for decimal input 8 and 9, the D is 1 1. So we can write the equation for D as a D is equal to 8 plus 9. Similarly, if we observe a C output, for that output is 1 only for 4, 5, 6 and 7. So the expression for C is 4 plus 5 plus 6 plus 7. For the B output, the output is 1 for the input 2, 3, 6, 7. So expression for B can be written as 2 plus 3 plus 6 plus 7. And for similarly we can write expression for A as a 1 plus 3 plus 5 plus 7 plus 9. And using this expression we can draw a logic diagram. We require here the 10 input lines from 0 to 9. These are the input lines. And for D, a OR gate is used to get 8 plus 9. For C, another OR gate is used to OR 4, 5, 6, 7 input lines. For B, another OR gate is used to get 2 plus 3 plus 6 plus 7. And lastly, for A, another OR gate is used to get A as a 1, 3, 5, 7, 9. That is 1, 3, 5, 7 and 9. These lines are connected to OR gate to get A output. This is how we can implement a decimal to BCD output encoder. Now we will see the decimal to BCD encoder IC, that is IC 74147. This is the pin configuration of IC, which is having 16 pins from 1 to 8 and 9 to 16. To 8 a ground connection is given, to 16 a VCC connection is given. Now here A1 to A9, these 4 and these 5, these are the decimal inputs, and this D bar, C bar, B bar, A bar, these are the BCD outputs. And pin number 15 is NC, means no connection is provided to that pin. This is the logic symbol. These are the 10 inputs from 0 to 1 to 9, and these are the 4 outputs, A bar, B bar, C bar, D bar. If you observe, all the input lines and output lines are active low input lines, means they are active when we connect a 0 to them. This IC configuration can be used while doing the practicals. Now next we will see the octal to binary encoder. This is the block diagram of octal to binary encoder. It is having 8 inputs from D0 to D7 and 3 output lines, that is B0, B1, B2. This encoder converts a octal number into the binary number. You will see the truth table of octal to binary encoder, which is having inputs from D0 to D7 and output B0, B1, B2, B3. In the first condition, when D0 line is 1, we will get output as a 0, 0, 0. When D1 is 1, we will get output as a 0, 0, 1. When D2 is 1, we will get output as a 0, 1, 0. When D3 is 1, we will get output as a 0, 1, 1. When D4 is 1, we will get output as a 1, 0, 0. When D5 is 1, we will get output as a 1, 0, 1. When D6 is 1, we will get output as a 1, 1, 0. And when D7 is 1, we will get output as a 1, 1, 1. This is the function of octal to binary encoder. And from this we are going to find the expression for B0, B1, B2. Similarly, as we have written the expression for decimal to BCD, in the same way we are going to write the expression for B0, B1, B2. If we observe a B0 column, then a B0 is 1 only when D4, D5, D6 and D7 are 1. So B0 can be written as D4 plus D5 plus D6 plus D7. Similarly, expression for B1 and B2 are written over here, and using this expression we can draw or we can implement the octal to binary encoder, which is having 8 input lines. So we require D0 to D1, D0 to D7 lines, and using these lines we can get the outputs. For B0 here a OR gate is used. To that D4, D5, D6, D7 lines are connected to get final B0 output. To get B1 another OR gate is used, to which D2 line, D3 line and D6 and D7 lines are connected to get B1 output. And to get B2 another OR gate is used, to which D1, D3, D5 and D7 lines are connected to get final B2 output. This is how we can design a octal to binary encoder. Now next we will see the IC for octal to binary encoder, that is 74148. This is the pin configuration of IC 74148, and this table shows the pin description. This is a 16 pin IC. From pin starts from 1 to 8 and 9 to 16. Now here the I0 to I7, these lines are active low inputs, means they are octal inputs. A0 to A2 lines are active low outputs, means a binary output can be observed over these lines. EI bar is the active low enable input terminal. If EI bar is at logic 1, then it will force all the output to become high, that is inactive. This feature can be used to allow some time for the new input data to settle down. GS bar is the group signal output. It is used for indication that one of the input is low, that is active. If all the inputs are inactive, that is high, then the enable output goes to logic 0. This pin means enable output works as a 0 when all the inputs are inactive. This pin configuration will be helpful for us when we perform the practicals in the laboratory for the purpose of giving the inputs and observing the outputs as per the functionality of this octal to binary encoder. Thank you.